are looking at another interesting topic in mathematics, which is foundational to the many applications that we have in mathematics. Mainly, this is what I call part of the backbone of mathematics, which includes Algebra 1 and Algebra 2. So we'll be mainly focusing on factorization versus expansion. And you will notice that if factorization is actually the opposite of expansion, and expansion is also the opposite of factorization. So what we'll be looking at in terms of factorization, we have in fact 4 types or 4 methods of factorization, depending on the type of expression that you will have. So we have a way in which we factorize simple expressions, which I will demonstrate, and this one is mainly where you take out the highest common factor, and it has a lot of applications. The second one, we'll be looking at the quadratic expressions, which has to do actually something that you will need to also apply when you are solving quadratic equations. So it's one of the important subtopics when it comes to quadratics, and you will notice that when we are expanding, this will give us a quadratic expression, and when you factorize, it gives you a double bracket. And then the third one is called the difference of two squares. So as the name suggests, or as it implies, it has to do with when you are subtracting two squared values. So it could be a square number or a squared term. And then the difference simply means a minus in mathematics. And then this last one is particularly exclusive to extended. So where you factorize by completing the square. So this is basically just to highlight changing an imperfect square binomial or trinomial, imperfect trinomial, into a perfect square trinomial. So, well, unfortunately, for today, we'll be focusing on the core curriculum. So we'll only do the first 3. So let's start with simple expressions. So there are quite a number of these simple factorization of simple expressions. So this is algebra 1. So the key rule, it is to take out the highest common factor. Take out the highest common factor. HCF. Take out the highest common factor. So one example that I can pick is this one, and then I'll also give more. So if you've got PM minus M, so what you need to note is that what is the common factor? And we are talking about a common factor. That means it's a value that is on both sides of the expression. Now, terms can only be separated by a plus or a minus or even an equal sign. In other words, this means there are 2 ways in which you can separate terms, using an operational sign or an equal sign. So in this case, this is a 2-term expression. So it is separated by this minus, so for PM and M. So when we are saying take out the highest common factor, you will notice that we have a common factor here, which is M. This is our first expression. And we also have this common factor on the second term. So that means we will take out M and we'll be left with P minus 1. So this is how you factorize this. And then in order to check or to test that this is correct, what you will do, you will expand. I've already highlighted that the opposite of factorization is expansion and vice versa. So it works hand in hand. So if I expand, I will get this expression again. So that's how you can check if your answer is correct. So you do it by doing this. M times P is PM, which is the first term, and M times -1 is -M. So basically this becomes a single bracket. Or in simple terms, you can say when you are simplifying simple expressions that are two-termed, you will form a single bracket with a scalar. So let's put a second one, in which now we will have ax cubed minus x. Yeah, let's do this one. And then I'll also show another one. Ax cubed minus x. So again, you're going to look at a common factor. So the first two examples that I'm showing will be quite easy, and then we will gradually move into complex factorizations. So you notice again, we do have an x here. In fact, there are 3, and then we have an x here, 1. So the highest common factor is x. So we will take out x, we'll be left with ax squared minus 1. So what is important here to remember is that when you are factorizing, you will also need to remember your directed numbers 1, and you will also need to remember your indices. So the reason this is x squared is because you notice that when you multiply indices of the same base, you add the powers. So this is actually x to the power 1. So x to the power 1 times ax squared would be ax to the power 3, because it would be 2 plus 1 to give us a cube here. And then of course x times negative 1 is x. Right. Let's move on to a third one. So this was the second. So the third one we can have, I want to include numbers now. So let's say we've got 2x squared minus 8ax to the power 4. Yes, to the power 4. Now, in this case, we will not only focus on the algebraic terms, which are the letters, but we will also need to consider the numbers as well. So you notice that there is a 2 here, and there's an 8, and they are common factors between 2 and 8. So what's the highest common factor between 2 and 8? It is 2. So we're going to take out 2. And then also, after we've taken out the 2, there's another term we can also take out here. Notice that we've got x squared, that means a different highlight. We've got x squared, and we also have x to the power 4. So now, the highest common factor will not be just be x, but it will be x squared. Excuse me. So we will take out 2x squared, so that in brackets we will have 1, and then we'll be left with 4ax squared, like this. So this will give us 2x squared, 1 minus 4ax squared. So hence, when you check, it should take you back to the original value. Let's check. So 2x squared times 1 is 2x squared, and then 2x squared times 4ax squared is actually 8ax to the power 4. So these are the first 3 examples that we have in terms of simple expressions. Right. Now, one student might ask, why can't we further factorize this? You might think this looks like a difference of 2 squares, but it's not. In as much as 1 is a square number and 4 is a square number, x squared is also a square number. The problem is that we have that a here. So you can't, this is not a difference of 2 squares. Unless the a was squared, then it would be a difference of 2 squares. And I will show how we factorize that in the last section. So the next part which I want to demonstrate now, it is how we can factorize quadratic Maybe before we factorize quadratic expressions, notice that I did mention that the opposite of factorization is expansion, and the opposite of expansion is factorization. So I can start by demonstrating the expansion so that I will also show the reverse of that as the factorization. So expansion versus factorization. Now, in this case, with respect to quadratic expressions. So you notice that in fact this, when it is factorized, it will be x plus 2, x plus 2. So we need to first expand x plus 2 and x plus 2. You will notice that it will give us this expression, and then I'll also demonstrate how we factorize to get back to that. So when we expand, this is how you do it. I'll show you the working. I will show you a shortcut after I've explained or demonstrated this quite explicitly. So when we are expanding in details, you break down the first bracket such that you have x plus 2, and then multiply each term by the second bracket. So each term in the first bracket will be multiplied by the second. At least that's how my teacher taught me, and it was quite easy for me to understand. And I hope it's quite easy for you as well. So it will be x plus 2 plus 2, x plus 2. Then what is x times x? So notice we have got two single brackets. X times x. The principle is you always multiply each and every term inside. So x times x is x squared, and then x times 2 is positive 2x, plus 2 times x is another 2x, 2 times 2 is 4. And then what we're going to do is collect like terms. So this is how we collect like terms. X squared will give us x squared. 2x plus 2x is 4x plus 4. So notice that this is exactly the same as that. So the expansion will give us the quadratic, the expansion of a double bracket. This is called a double bracket. So the expansion of a double bracket will give us a quadratic expression. And the factorization of a quadratic expression will give us a double bracket. So now I want to demonstrate that in fact, when we factorize this x squared plus 4x plus 4, it will take us back to that double bracket. Now the question is, how do we factorize a quadratic expression? So you will recall that a quadratic expression, it is called a quadratic because it has the highest power of x being 2, and it is a three-termed expression. The first term is the value that has the highest power of x being 2, and the last term or the third term will be a constant, positive or negative. And the middle term will have a coefficient. So the coefficient of the middle term is what we need to focus on, and also the constant. Mind you, remember that also we also need to mind the value of a. So in this case, because we have the value of a being 1, we will just focus on the constant only. but I will show you a case where the value of A is greater than 1. So in this case, the value of A, because remember a quadratic expression is always written in the general equation, or rather general expression, which says ax squared plus bx plus c. So if the value of A, like in this case, A is equals to 1, we will only focus on the value of B and C. So what is the significance of the value of B and C? So the value of C, we are supposed to focus on the product, and the value of B, you are supposed to focus on the sum. Now, what is sum product? So the product is important because we need the factors of 4 in which their product will give us 4 and their sum will give us 4 again. So you notice that, or maybe let me ask, what are those vectors? When you find the products, they give you 4, and when you add, they give you 4. So you notice that it is 2 and 2, because 2 times 2 is 4, and 2 plus 2 is 4. And then from there, remember, I did mention when we were solving quadratic expressions that if the value of A is 1, you don't really need to do equal-ping. You just write this like that, x plus 2, x plus 2. So notice that this factorization is actually giving us the double bracket. Hence, the reverse of expansion is factorization, and the reverse of factorization is expansion. Now, actually, or maybe I'll give you the example, rather the tip in the end, because I did show you that I can give you a clue on how to expand this without doing a whole lot of these details. But of course, it's important that you understand this first. So I think it will be my last demonstration. Now, the next one which I want to show, still on the factorization versus expansion, is a case whereby, let's say now we are expanding where, because I'm not sure if you have noted, the example that I just demonstrated, the double brackets have same values. It was x plus 2, x plus 2. But now I want to show a value that gives different values and where the value of A is greater than 1. So let's say we've got 3x plus 1 and x plus 2. So I'll demonstrate how you expand this to get the quadratic expression, and then I'll also show you the reverse of that, which will be the factorization to get back to that value. So hence I'll write these arrows like that. Now, so in this case, again, like I said, you split the first bracket and then multiply each term by the second bracket. So it would be 3x, x plus 2 plus 1. Please remember, yonke iterm ihamba nesign yayo. So this is not just 1, but it's positive 1. If it was a negative, it would have been negative 1. So, x plus 2. So this will give us 3x squared. Again, remember, let me highlight. It is 3x times x, 3x times 2, and positive 1 times x, positive 1 times 2. So this gives us 3x squared, excuse me, plus 6x plus x plus 2. Then we collect like terms, 3x squared plus 5x plus 2. So this is the answer that we have. So this is how we expand, and when we expand, we get a quadratic expression. Now, I'm going to take the same quadratic expression and demonstrate the reverse of it, which will take me back to this double bracket. Now, what you will notice in this case, the value of A now is what? Is greater than 1. So the principle that we will use here will be slightly different. So notice I said if the value of A is 1, we only focus on the value of B, the coefficient of the middle term, and also on the value of C, which is a constant. But if the value of A, like in this case, is greater than 1, we need to then focus on all the terms, in fact. Focus on A, focus on the middle term, and also focus on the constant. So the first step would be multiply the coefficient of x squared by the constant so that we form a new value of C, or a new constant. So 3 times 2 will give us 6. And we will write it here. So now we no longer look for the factors of 2, but we'll now look for the factors of 6. Or in other words, just like I've written in the previous example, we will want to find the factors that will find or that will give us the product of 6 and the sum of
7.
Sum of
7. X plus 6x plus 1 is 7.
Where? Oh yes, thank you. So this is supposed to be 7 because I did the subtraction. It's supposed to be 7. Thank you for noting that. So it's supposed to be 7 here. Yes. So in this case, our middle term will be 7x, and the coefficient of the middle term is 7. So that means now we're looking for the product should be 6 and the sum should be 7. Right. So you notice here that the factors will just be 6 and 1. So positive 6 and positive 1. So 6 times 1 gives us 6, and 6 plus 1 gives us 7. Right. And then another step which should be very important is that this term will be written as it is, 3x squared, and this term will be written as it is, plus 2. Then, instead of writing 7x, we will write 6x plus x. In other words, you simply write the factors in terms of x. 6 becomes 6x and 1 becomes x. Then plug them in the place of 7x. Then, of course, we do what we call a grouping. And grouping simply means you group the first 2 terms and group the last 2. Then take out the highest common factor to factorize this. So therefore, the highest common factor here would be
3x.
Yes, 3x. So we're left with x plus 2. Then remember, when you're factorizing a quadratic, always the middle, or rather the values that are in the bracket should be exactly the same. So you've got 3x, x plus 2, and plus 1, x plus 2. So the answer, you will notice that it is exactly as that double bracket which we got. So we combine these scalars, 3x plus 1, with x plus 2. So this will be the answer. So hence, the opposite of expansion is factorization, and the opposite of factorization is expansion. So this is still the same as that double bracket, and when you are factorizing this, it gives us that double bracket. Alright, now you will notice that We did solve that one, so now I want us to solve this one, the third one. So how we can factorize this? So it will be a second example for our demonstration. Okay, so let's factorize 3x squared plus 4x plus 1. So notice, like I said, because the value of a is greater than 1, we will multiply that 3 times 1 to get a new constant, which will be 3. And then we know that 3 is a prime number, so it has 2 factors, and that is 1 and 3. 1 times 3 is 3, that's the product. So product and sum. So the sum will be the value that is in the middle, so sum. So the product of 1 and 3 is 3, and the sum of 1 and 3 is 4. So these are the factors. And then because the value of x squared has a coefficient which is greater than 1, so this will remain as it is. And then we'll write these factors in terms of x. So 1 becomes x and 3 becomes 3x. So it will be plus x plus 3x. So we're now actually forming 4 terms. Then in grouping, group the first 2 and group the last 2. Take out the highest common factor. In this case, double 1. X, yes. Second, 3x plus 1. Then I remove 1 so that I remain with 3x plus 1. Like I said, remember always the values that are in the brackets should always be the same. That's how we check if it is correct. Then combine the scalars x plus 1 and 3x plus 1. So this is how you will get the answer. So this is how you factorize a quadratic expression. Right. Now, before I show the difference of two squares, here are some tips that I want to give you on how to identify. I'll start with a couple of general expressions to show E expansion. For instance, A, so the general expressions. So when you've got A plus B squared, this is not A squared plus B squared, but it is equal to A plus B, A plus B. And then because the values that are in the brackets, in this double bracket, they are the same, the answer will be A squared plus 2AB plus B squared. Now the question is, how do I get this? To get this, once the brackets are fanana, you just choose one. We'll see A squared for the 9. B squared for the 9. Then A times B, or AB, times 2 for the 9. So, which means you can always expand a double bracket that has the same values without stressing yourself with breaking up the first bracket and multiplying each term by the second bracket. Once you have number terms, just choose one, focus on the first one, a value, that value squared, you write it as the first term. The second value squared, you write it as the last term, and find the product of the terms and multiply by 2. That should give you. Then the second one is the one which includes a negative. It is like this: a minus b squared is the same as a minus b, a minus b. And this one, the answer is a squared minus 2ab plus b squared. Again, I need to prove this one to show you that it is indeed like that. Now, since the values in the brackets are the same, that's a squared, focus on one bracket, you get a squared the first term. Negative b squared, remember, okay, you tell mama and sign here. Any negative squared will always give a positive. So, b squared, then a times negative b is negative ab, times 2 is negative 2ab. So this is how, these are the expressions that you can always remember in order to expand a double bracket that has the same values or the same terms. Okay. So now we can move on to the difference of two squares. The difference of two squares. So I have already highlighted that it comes from the definition itself. A difference in mathematics simply means subtract or minus. So difference simply means minus or subtract. And then two squares, or maybe let me just, squares has to do with square numbers. Can be square numbers or squared terms. So 4 is a square number, 1 is a square number, 25 is a square number, 36 is a square number, 9 is a square number, 49 is a square number. So basically, a square number is the result that you get when you multiply a number by itself twice. So if you take the natural numbers and just square them, the result will always be a square number. And then also, when we are saying squared terms, we simply mean x squared is a squared value, which is a squared term, y squared is also a squared term. So for instance, here are some examples of a difference of two squares, and I'll also show how to factorize them simply. So x squared minus y squared, this is the difference of two squares. And then 1 minus m squared, it's another difference of two squares. 3 x squared minus 25 is a difference of two squares as well. Then maybe 4x squared minus 16a squared is another difference of two squares. Now, how do we solve such cases? So this is what you do. You simply Find the square root of the first term and find the square root of the second term, and then write them as a double bracket with opposing signs. What do I mean? What's the square root of x squared? X. What's the square root of y squared? Y. So then you write this in terms of a double bracket with opposing signs. So which means that one x minus y, which means that we're x plus y. We will prove this by expanding, so that you can see that when you expand it, it will take you to the initial one. Now, looking at 2, again, you will do the same. Find the square root of 1 and find the square root of m squared. So the square root of 1 is 1. The square root of m squared is m. Then write that as a product with opposing signs. So it's 1 minus m, 1 plus m. As a product of the terms with opposing signs, but still in brackets, so which means it becomes a double bracket with the same terms but opposing signs. Now 3, the square root of x squared and the square root of 25. So the square root of x squared is x and the square root of 25 is 5. And write this as a double bracket with opposing signs. Now the last one is particularly interesting, because for starters, the numbers are the ones which are squared values, and also the terms. So what you can do now, 4x squared is in fact a squared term and 16a squared is a squared term. So you can simply find the square root of that and the square root of that. So this will give us 2x and 4a. So minus like that, and then 2x plus 4a. Now, in fact, this one is interesting because do you notice good to we still have a common term inside, which is 2. So you can still take out the 2 and then have something like this, x minus 2a and x plus 2a. So this will be the answer. So the reason that I was showing you this is for you to see that even the numbers can be involved in terms of square numbers, not just the terms. Right. Now let's do this one, which I have demonstrated here as a. So let's do this one as our final example. So you notice that in this case particularly, we've got 32m squared minus 18n squared. So what is wrong with this one? Or is there anything wrong with this one? If you look at the numbers, what's wrong? Is 32 a square number? No. Is 18 a square number? No. But this is still a difference of 2 squares because this is a square term minus another square term. So the reason we cannot factorize this as it is, there is something that we will have to do before we factorize. It is because if you say the square root of that, you can only get the square root of m squared. You can't get the square root of 32. It will be a decimal value. Even in this case, you can get the square root of n squared, but you can't get the square root of 18. So the first thing that we'll have to do we'll need to take out a factor between 32 and 18. That will help us to get, in fact, is the highest common factor between 32 and 18. Or a factor of 32 and 18, that which when we take out, it will give us squared values inside. You'll notice that if you take out 2 as a factor, you'll be left with 16m squared minus 9n squared. So now this becomes accessible and quite easy to solve, because now we know that 16 is a square number and 9 is also a square number. Then we can do what we've done in all our examples, the square root of that. So we still have the 2 here, it will be 4m squared minus, 4m rather, because it's the square root of 16 is 4, the square root of m squared is m, minus 3n, and then 4m plus 3n. So this is what I wanted to demonstrate as our last example, because it is often tricky, such particular values. So it's important that when you are solving specifically the difference of two squares, you pay attention to all the terms and the coefficients and the values, how they look. Because you can't say this is impossible. There is a way to make it possible, which is what we have done. We've taken out the highest common factor, 18 and 32, or a factor that helps us to get square numbers. And then it's easy to find the square root of that and the square root of the other. Otherwise, this is how we do factorization and expansion. And of course, as I highlighted, the last one, which has to do with completing the square, we shall do that one in an extended lesson. So this one was a core lesson. So with more practice, you will notice that this will become easy. Otherwise, our lesson for today, it ends here. Cheers.